All right, guys, let's go ahead and get started. So we're going to start by solving 6x squared minus 17x plus 12 equals 0. So we're going to start off with some factoring polynomials, getting used to this stuff because, again, we're going to keep seeing it over and over again, and it's not going to be going away. So the first thing that we do with these is we look for a GCF between all three terms. So any numbers that go into all three evenly besides 1. And there aren't any GCFs here. So we don't even need to do this step, but of course we always want to check because if we can, then it will save us some time. So after we do that, if there is no GCF, I'm going to go ahead and take my A value and I'm going to multiply it by my C value. So 6 times 12 will get me 72. From here, we're going to look for numbers that add to be negative 17 and multiply to be 72. Now there's a lot fewer numbers that will multiply to be 72. So we're just going to go ahead and list out all those factors. So we have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. And on top of that, we also have all the negative combinations here as well. Out of all of these, the numbers that will add to be negative 17, well, this will give us negative 73, negative 38, negative 27, negative 22, negative 18, negative 17. Well, we found our two terms, negative 8 and negative 9. So we go ahead and we put those inside both of our bubbles. So we have x minus 8 times x minus 9 equals 0. So that's where those two terms came from. From here, we're going to take our a value. We multiplied it at the start, so we need to undo that now. So I'm going to divide both terms by positive 6. When I do that, I'm going to go ahead and reduce my fractions. That gives me x minus 4/3 times x minus 3/2. And of course, it's still set equal to 0. At this point, if it has its own bubble, it gets its own equation. So x minus 4/3 equals 0. X minus 3/2 equals 0. From there, we can see our two answers. We have our answer as x equals 4/3 and x equals 3/2. Just by solving these two equations, by adding 4/3 to both sides, and then by adding 3/2 to both sides as well. So again, let me just go ahead and post all this back up. So again, we can see both of our answers, x equals 4/3 on the left here, and on the right we have x equals 3/2. And again, you can write those as fractions or decimals, so you'd have 1.3 repeating, or you'd have 1.5. All right, so today we're going to be covering 4.3, the case of the missing diagram. Our learning target: I can create the given conclusion diagram and write the proof given just a verbal statement. So they're going to give us a verbal statement. We're going to have to prove what's happening in these. So let's go ahead and get started. Example 1. If two altitudes of a triangle are congruent, then the triangle is isosceles. So they give us a conditional statement for number 1, which is really nice because the conditional statement kind of tells us what's given and what we need to prove right away. Now, the first thing that you're going to do in all of these problems is you're going to draw your picture. You need to draw a picture of whatever we're dealing with in order to see what we actually have to work with. So in this case, they give us if two altitudes of a triangle are congruent. So what I need to do is I need to draw a triangle, and that triangle is going to have two altitudes. So let's go ahead and start off with that. Here's my triangle, and then I'm going to have two altitudes, and again, our altitudes go from the vertex of a triangle and intersect the opposite side at 90 degrees. That's the definition of an altitude. That's what an altitude is. Now, we're going to go ahead and label up this triangle. So we're going to call it triangle ABC. And then we're going to have our intersections of the altitudes at point D and point E. Now, from here, they tell us the two altitudes of a triangle are congruent. So that's going to be part of our given. We're going to have that AE is congruent to CD. The other thing that we're given is that AE and CD are altitudes, because that's what they tell us. They're two altitudes. So that's what's given to us. What we would like to prove is in the second part of our conditional statement. We'd like to prove that triangle ABC is isosceles. So we can go ahead and write all this down now. Let me go ahead and get rid of my drawn-in labels. So now we have that AE is congruent to DC. Those are our two altitudes. And that AE and DC are altitudes. Again, we're trying to prove that triangle ABC is isosceles. So now we prove this. So the first thing that we're going to do in our proof is write our given information. AE is congruent to DC. AE and DC are altitudes. That's given. From here, let's go ahead and focus on the definition of an altitude. Now there's multiple ways that we can go through this, but the quickest way for us to solve this is to show that we have two congruent legs. We can prove that either the legs are congruent or the base angles are congruent, then we're good to go. So there's multiple ways to go through this. Now the way that I'm going to go through this is I'm going to prove that the two top triangles are congruent. The two top triangles are congruent. That will automatically give me two side lengths of the large triangle ABC, which will allow us to say that it's isosceles. Now, if I'm focusing on the triangles up top here, triangle ABE and triangle CDB, then the next thing that I'm going to do is I'm going to go ahead and say that these two angles, angle CDB and angle AEB, that those are right angles. And the reason I can say that these are right angles is based upon altitudes. I know altitudes will intersect the opposite side at 90 degrees. So that's why these two angles are right angles. And further, if they're both right angles, that means that they are also going to be congruent to each other. So AEB is congruent to angle CDB because all right angles are congruent. Now, we already have angles, and right angles automatically opens up HL for us. It's a possibility. It's not necessarily going to happen, but it's on the table for us. We also already have these two sides being congruent from our given information. So next up, is there anything that's shared by the two overlapping triangles? Well, yes, they both share a common angle. They share angle B. So I can now say that angle B is congruent to angle B, and the reason I can say it's congruent to itself is always going to be by the reflexive property. So that's why those two angles are congruent in each triangle. Now from here, we have enough information to say that the two triangles are congruent. Triangle ABE is congruent to triangle CBD. Now the reason that we can say this, and again, we're just going to read our congruency marks. We have angle, angle, side. Now if you're reading that and you get angle, side, side, or side, side, angle, and you have a right angle here, that would be HL. But however, right here we have angle, angle, side. And that's our last triangle congruency postulate that we learned. So that's acceptable. So those two triangles are congruent by angle, angle, side. Now, if these two triangles are congruent, I see that AB is a segment of these two triangles up top. I can say the same with BC with our corresponding triangle. So therefore, I can now say that AB is congruent to BC. And the reason I can say that these two segments are congruent is based upon number 5, the triangle congruency. If I see that two triangles are congruent, that means that all the corresponding parts are. So I see that AB is written first, CB is written first, so those are corresponding parts. So therefore, those corresponding parts are congruent, because if triangles are congruent, then corresponding parts of congruent triangles are congruent. CPCTC. Now lastly, if those two segments are congruent, these two legs are congruent, I can finally say that triangle ABC is isosceles. And the reason I can say that is the definition of isosceles. If at least two sides of a triangle are congruent, then that triangle is an isosceles triangle. And with that, this proof is finished. So we've now finished up this proof. So pause the video if you need to finish this up, but we have now completed our first one. All right, let's go ahead and continue on. Here's example 2. You can go ahead and pause the video, try this one out if you'd like, and then we'll work through it together. If you get stuck, it's fine to unpause it, and then we can try it as well. So example 2, the altitude of the base of an isosceles triangle bisects the vertex angle. So this one isn't a conditional statement. We need to piece together what we have. So first off, I know that we have a triangle, so I can draw a triangle. Specifically, this is an isosceles triangle. So if I draw an isosceles triangle, it's also going to have an altitude to the base. So my altitude will go from my vertex angle to the base of my triangle. So again, we draw our isosceles triangle. Our vertex angle is the very top, where point B is at, and it goes down to the base, which is base AC. So I can see that this would be my altitude here. So with that information, what we're given is we're given that ABC is isosceles, and we're also given that BD is an altitude? What we'd like to prove is that the altitude bisects the vertex angle. Well, our vertex angle is angle ABC, this angle right up here, and we want to know if our altitude bisects it. So does BD bisect angle ABC? So we now have our given and our proven. BD is an altitude of triangle ABC, and triangle ABC is isosceles. We want to prove that BD, our altitude, bisects the vertex angle, angle ABC. All right, let's get started on this. We start off with our given information. BD is an altitude of triangle ABC, and triangle ABC is isosceles. Now again, I'm going to focus on altitude first. An altitude goes from the vertex of a triangle and intersects the opposite side at 90 degrees. Therefore, I can say that angle ADB and angle CDB are right angles. And again, that is because an altitude intersects the opposite side at 90 degrees. From here, I'm going to go ahead and move on to the second part of our given, that ABC is isosceles. If ABC is isosceles, we know for a fact that that two of the legs are congruent. Now, we already know that AC is our base, because again, our altitude is going to the base. If our altitude is BD, I see that's intersecting the base AC. So that means that AB and BC are our legs. And if this triangle is isosceles, which is given to us, then I know that those legs are congruent. So I can say that AB is congruent to BC, and that's by the definition of an isosceles triangle. The legs of an isosceles triangle are congruent. From here, we're looking at these two triangles, triangle ABD and triangle CBD. With these two triangles, is there anything that they share? Well, yes, they both share segment BD. So BD is congruent to BD by the reflexive property. If that's the case, we now should have enough information to prove that the two triangles are congruent. If we read our triangle congruency marks, we have angle, side, side. But that's not a postulate. However, we have a right angle, so that's enough for HL. So let's see if HL works. We have our hypotenuse, the side opposite the right angle, and we have a leg. We also have a right angle, so therefore triangle ABD is congruent to triangle CBD by HL. Again, we have a hypotenuse, and we have a leg, and we have a right angle. All right, now if the two triangles are congruent, well, let's go ahead and focus in on what we're trying to prove. BD bisects angle ABC. If we want to prove that, then we need to prove that these two angles up top, angle ABD and angle CBD, are congruent. Well, those two angles are in fact corresponding angles. And since the two triangles are congruent based upon statement number 6, I can say that angle ABD is congruent to angle CBD. Because if triangles are congruent, which we see in number 6, then the corresponding parts of those congruent triangles are also congruent. So therefore, those two angles, ABD and CBD, are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. Well, if those two angles are congruent, then as we said, we can say BD bisects angle ABC, which is what we're trying to prove. And the reason that we can say that is because if a segment splits an angle into two congruent angles, then the angle is bisected. And with that, this proof is now complete. All right. Thank you guys so much for watching today. I really do appreciate it. If you guys have any questions, any confusion at all, please let me know. I want to help you guys out. Other than that, thank you guys so much for watching. I'll talk to you soon. Have a great rest of your day. Take care.